I'm going to do a quick lecture on turning sums and differences into products, a couple of special case situations, which are not hard to learn. It just takes a little effort on your part. And really, what I just said is true. So let's look at 9 minus 4. It turns out that's equal to 3 plus 2 times 3 minus 2. And I encourage you to hit the space bar right now and see if you can draw the picture associated with the sentence that I just wrote. All right, I'm going to keep talking. So if you want to try to draw the pictures associated with the numbers on the board, think about it for a half a minute or a minute. If you come up blank, I'm just going to keep talking. You want to be familiar with numbers like 4, 9, 16, 25, 36, 49, perfect squares. So it's easiest to see by drawing some squares. What are 3 and 2 and 3 and 2 and whatnot? They're the what? The square roots. So it turns out that 9 minus 4 can be written as the sum of the square roots, 3 plus 2, which is 5, times the difference of the square roots, 3 minus 2, which is 1. And 5 times 1 is another way of saying 9 minus 4. But now it's a product. So we could always change this to any numbers we wanted. One of the things we're trying to learn is if this is 7, then that's the square root of 7. If this is 5, then that's the square root of 5. Now, I don't think anybody's going to ask you to factor 7 minus 5, but you could. 7 minus 5 is 2. And so we could get the square root of 7 plus the square root of 5 times the square root of 7 minus the square root of 5. And yeah, we're trying to get you to learn the square root of 7 times the square root of 7. Okay, well, that's this picture. I think we have been talking to the class about the square root of 7 times, that's the square root of 49, which happens to equal 7. So we're hoping you can see this and go, oh, skipping this step. Oh, I know what the square root of 7 times the square root of 7 is. It's 7. That's a skill you got to develop. What's another way of saying the square root of 7 times the square root of 7? It's the square root of 7 squared. A couple of inverse operations. I hope you can see the number 7 that way as well. So the square root of 7 times the square root of 7 is 7. The square root of 7 times minus root 5 is minus root 35. I didn't draw that. I didn't write that too well. Minus root 35. And the square root of 5 times the square root of 7 is the square root of 35. And the square root of 5 times minus root 5 minus 5. I hope you can see the middle terms are canceling because of the plus minus form. All right. So I might as well do one more. And this will be a harder one than you probably see on a test for a while. But I could easily do 49x to the 6th minus 9. Well, all you need to know is 7 times 7 gets you 49. What times what gets you x to the 6th? X to the 3rd, x to the 3rd. So 7x to the 3rd times 7x to the 3rd gets you that. And 9 gets you that. So what's another way of writing 49x to the 6 minus 9? It's the sum of the square roots times the difference of the square roots. And I'm going to make a rapid fire 5 video that shows that 5 times in a row. By the time you get to the 5th one, I hope you got it in your pocket. All right, we can also work with cubes. What are the numbers that are user-friendly for cubes? 8, 27, 64, and 125. Those are the ones you need to know for high school. 125, 5 cubed, 64, 4 cubed, 27, 3 cubed, 8, 2 cubed. Okay, so that means if I was looking at 27 plus 8, which happens to equal 35, and the cube root means I'm dealing with cubes. Didn't draw that one too well. Give me something to work with here. Yeah, that's a little better. Okay, well, you're looking at a 3 and a 2. Now, what is 35? Well, 35 is 5 times 7. Well, I think I can see where the 5 comes from. it's the sum of the cube roots. And it turns out to get 27, I gotta get the other two dimensions, you know, the 3 times 3 part. I got the 3, and 3 times 9 is 3 times the other two parts, right? Length, width, and height from the shapes. And I gotta get the number 8, which is 2 times 4. So I think next time I get a more complicated one, if I can just get the first parentheses, then these numbers are just the squares, and they go at the beginning and at the end. But now I have 5 times 13, and I want 5 times 7. So somebody in history said, oh, how about we throw a -6 in here? And then it's true. Well, if I have the first two numbers, how do I use them to make this? I think I just multiply and change the sign. Okay, so let's do one. Let's do the sum of 2 cubes one time. We'll do 5 of them in a rapid fire 5 video, which I've already made. So let's look at, how about 125 x cubed minus 4 cubed is 64. Which one did I do last time? The minus or the plus? I did the plus, so I'll do the minus this time. 64y cubed. You pause the video and try it, and I'll just do it out for you and we'll check it. I want the cube roots, which is 5x minus 4y in this case, because it's a subtraction. I'm going to square the first term, that's 25x squared. I'm going to look at the product, which is minus 20xy, that's the product. I'm going to change the sign because I need cancellation. And that'll probably take you a couple of practices to get it wrong before you get it right. And I'm going to square the last term. And when you square a term, you always get a positive. 16y squared. And I'll multiply this out just to show you that it comes right back to that. And the best way to multiply that out is across and underneath, put it into columns. 5x times 25x squared, 125x cubed. Yay! 5x times 20xy, 100x squared y. 5x times minus 16y squared is positive 80xy squared. 80xy squared. Now, these terms don't show up. I better get some cancellation between this plus minus. Let's find out if we get it. All right, so now I'm doing minus 4y times each of these things. All right, minus 4y. Minus 4y times 25. Well, that's minus 100x squared y. Oh, minus 100x squared y. Oh, good. Got 2 of them out of 1. Okay, minus 4y times 20. Minus 4 times minus 80xy squared. Minus 80xy squared. Yummy. And now minus times a plus is a minus. And I get minus 4 times 16, which is minus 64. Hope you can see everything good. And y times y squared is y cubed. Okay, so this gets some cancellation. Middle terms disappear. And I've got 125x cubed minus 64y cubed. Oh, that's what I started with. I guess I can do that. All right, that video is done. You look at it, you try to think about it, and if you don't look at it and you don't think about it, guess you're never gonna get it. But if you try a few times, you will. That's up to you.